In this problem, we're asked to solve this equation here. So notice it is a logarithmic equation. I have one log term here. I have another log term here. They're both base 4. But notice I have one term that is not a log. Therefore, what I want to do in this case, where every term is not a log, what I want to do is I want to write it in the form of log to the base b of u equals v. Then, if that is true, then I can write it in exponential form, b raised to the v equals u. So in order to get my equation looking like this, I need all my logs on one side. I'm then going to have to condense them, and I need to leave the plain old number 3 by itself on the right-hand side. So what I'm going to have to do is, the first thing I'm going to have to do is I'm going to have to add log to the base 4 of x plus 8 to both sides. So I'm going to get left with log to the base 4 of x minus 4 plus log to the base 4 of x plus 8 equals 3. Now what I'm going to have to do is condense these two logs so I just have one log term on the left-hand side. So remember the property of logs that says log to the base b of m times n is log to the base b of m plus log to the base b of n. So in this case, both of my logs are positive. So when you have two logs that are positive, what we have to do when we combine them is multiply the two arguments. So I'm going to have log to the base 4 of the quantity x minus 4 times x plus 8 equals 3. And so now I have one log on the left-hand side. It has a coefficient of 1, so it's in this format. So now I can turn it into the exponential form. So what is this in exponential form? 4 is the base of the log, so 4 has to be the base of my exponent, and it's 4 raised to the third power equals x minus 4 times x plus 8. So remember, all I'm using is if this is true, then this is true. b raised to the v equals u. So 4 raised to the third power equals this product. So now, all I have to do is work with this equation. Notice all my logs have gone. So I now have 4 cubed, which is 64, equals, I'm going to have to FOIL this out, x squared plus 8x minus 4x minus 32. So you can now see that I have a degree 2 equation. So what I need to do is get 0 on one side, put it in standard form. So 0 equals x squared, 8x minus 4x is plus 4x. I'm going to have minus 32 minus 64, since I have to subtract 64 from both sides to get my 0 over here. So I get 0 equals x squared plus 4x, and 32 and 64, that's going to give me negative 96. So hopefully this one factors. And since I have a 1x squared here, I know I'm going to have an x and an x. And I need two numbers that multiply to negative 96 and add to 4. And I think that's going to be 12 and minus 8. And quickly you can check it. X squared minus 8x plus 12x gives me plus 4x. 12 times negative 8 gives me negative 96. Remember, if you're having a hard time finding the factors, you can do yourself a little t-chart, and you write two numbers that multiply to negative 96, and they have to add to plus 4. So you can start with negative 1 and 96. Well, that obviously doesn't work. And you can just keep going until we get to the factors of negative 8 and 12 multiplied to negative 96, and they add to positive 4. So now all I have to do is set each of these equal to 0. And x equals, subtract 12 from both sides. Ooh, that's terrible handwriting there. Sorry about that. Let's start again. X equals negative 12 and x equals positive 8. But remember, these are only potential solutions. One, none, or both of them could be extraneous. So we must check. For every equation that has a log in it, you must check your answers. So let's go look on the next slide. So here we have our original equation and the two potential solutions we found on the previous slide. So let's start by checking x equals negative 12. That means wherever you see an x in the original equation, you're going to have to put a negative 12. So log to the base 4 of negative 12 minus 4. Now when we check these, to check for extraneous solutions, we want to make sure that the argument is a positive number. Well, what is negative 12 minus 4? It's negative 16. Is that a positive number? No. That means negative 12 does not work, and it is an extraneous solution. So now we go to our next one. Check x equals 8. And before I go on, one thing I want to point out is, notice I found the first argument was negative. I don't care what all the other arguments are. Directly you find the first one that crashes, it means it's extraneous. You don't have to check the rest of the equation. So let's go to checking x equals 8 in the original equation. So log to the base 4 of x is 8 minus 4 equals 3. Oh, I forgot to check. So let's look at what 8 minus 4 is. 8 minus 4 is positive 4. I'm happy. So far, so good. Equals 3 minus log to the base 4 of, remember, I'm plugging into this one too. X is 8 plus 8. Well, 8 plus 8 is 16. That's a positive number. That means this is not an extraneous solution. Therefore, what is the answer to this equation? The solution to this equation, it only has one answer, x equals 8, because x equals negative 12 was extraneous.